Hi, good evening. Yeah, good evening, everyone. Good evening. Yeah, I will add. I will add. Good evening, everyone. So, can you try this problem? What will be the answer for this? Try once. Let A be a sequence of 8 distinct integers sorted in ascending order. How many distinct pair of sequences of B and C are there such that each sorted array is ascending order? B has 5 elements and C has 3 elements, and the result of merging B and C is A. Can you guess what will be the answer for this? Try once. Yeah, there is tomorrow morning there is a DMS class. Today morning also there, but because of because of yesterday some program is there, so it affected. Today morning also there is a DMS class because of yesterday some program unknowingly, so it is shifted to day after tomorrow. Right, tomorrow there, tomorrow is there. Let A be a sequence of 8 distinct integers sorted in ascending order. How many distinct pair of sequences of B and C such that there is a right? First condition is each is sorted in ascending order. B has 5 and C has 3. And third one is the result of merging B and C is A. Right? What will be the answer? Right? Let's check. Let's check what will be the answer. Remember one small conditions are there. See this one. Let A be a sequence of 8 distinct. See this one. 8 distinct integers sorted means what I want to say. A is a sorted array. This one A is a sorted array. Something like this. A is a sorted array. Let me write 10, 20, 30, 40, 50, 60, 70, 80. 1, 2, 3, 4, 5, 6, 7, 8. A contain right 8 integers in the sorted order. And important thing is, listen, important thing is, let me say one small line. Let me say one small line. See this one. How many distinct pair of sequences B and C are there such that each is sorted in ascending order? B has 5 and C has 3. And one more. The result of merging B and C is A. So this A, right? You have to divide into two parts, B and C. B should contain 5 people. C should contain remaining 3 people. And one more thing if you observe, see this one. Each is sorted in ascending order. Means A contain 5 people in the ascending order. B contain 3 people in the ascending order. And result of A and B, right? Result of B and C will give, right? A. So this should be sorted. Remember everyone. If A contain 8 people, out of 8 selecting 5, 8 C5. If A contain 8 people, right? Out of them, if you select 5 people, 8 C5. 8 C5. How much 8 C5? How much 8 C5? 8 into 7 into 6 by 1 into 2 into 3. 8 C5. 8 into 7 into 5 by 1 into 2 into 3. Right? Am I right? Yeah, same. 8 C5. Same meaning. 8 C5 is nothing but 8 C3. right? 5, right? 8 minus 5 is going to be 3. So I think this is. Okay. So now see the answer. 8C5 is, right? 56. 8C5 is 56. Remember, out of 8 people selecting 5, that 56 ways are there. Out of 8 selecting 5, 56 ways are there. 56. But the interesting thing is 56 way. Let's take the first way. What is the first way? Let's see the first way. First way is 10, 20, 30, 40, 50. That's the first way. What is the second way? 20, 30, 40, 50, 60. Like that 56 ways are there. But remember, sorted array, if you take, right? Sorted array, if you take any combination, it will become sorted. Sorted array, any combination, it will become sorted. Please remember. That is the condition what he said. See this one. Each is sorted in ascending order. Out of 8 people, which is the sorted array, if you take 5 people, means you have to take a one combination. Out of 8 selecting 5. Out of 8 selecting 5, just right, one possible combination you take. Out of 8 selecting 5. So remember, sorted array combination, right? Sorted array combination, right? Out combination of 5 people, it will also sorted, because when you say combination, order no difference. But when you say permutation, then order difference will come. Remember, combination order doesn't matter. But permutation order matters. Out of 8 selecting 5, 8C5, 6. C means combination. Out of 8 selecting 5, 8C5, 56 possibilities are there. 56 combination. Remember, your order doesn't matter. See this one. Same order will be there. Sorted order combination is sorted order. Sorted order combination is sorted order. Now some people are asking, sir, out of 8 selecting 5 is 8C5, that's okay. But what about the C? Right, remaining people are 3. Out of 3 selecting 3. One way. So 1 into 56 is 56. So answer is 56. Answer is 56. So A, which contain 8 people, and one more thing is sorted. So this 8 will be divided into 2 parts, B and C. Right? So B is going to be 8C5. C is going to be 3C3. Combination. Right? Sorted array combination is sorted. Sorted array combination is sorted. So this is a very, very important point from this problem. This is a very, very important problem from this problem. Please let me know if anyone having doubt. Sorted array combination is sorted. Sorted array permutation, right? Order may be different, but a combination order there is no difference. Sir, I have a doubt how to ask you. Right? I think there is a one Telegram group, Unacademy, right? Unacademy CSE 2023. There is a one Telegram group, Unacademy CSE 2023. In that group, you can post. Distinct pair means nothing is common. Please explain distinct pair of sequences B and C. Means nothing is common. If you take 10 in the B pair, right, you have to take remaining in the C pair. Right? In the B, if you take 10, in the C, 10 cannot be there. In the B, if you take 20, in the C, 20 cannot be there. Someone is saying, sir, how C? How C? I already explained. See there, that is already there on the board. A contain 8 people sorted. You have to divide A into 2 parts, B and C. B contain 5 people from the A. Remaining people are in the C. Out of 8 selecting 5, 8C5, 56. Right? Out of 3 selecting 3 is 1. So everyone know 8C5 is equal to 8C3. Because NCR is equal to NC N minus R. There is a formula. NCR is equal to NC N minus R. Same way. Right? Srivastava is asking, can anyone give the Telegram link? I am saying, can't you type it? Srivastava, can't you type it? Unacademy CSE 2023. Unacademy CSE 2023. Check once. See, remember, some people are thinking, sir, out of 8, selecting 5, 8C5, okay, but those 5 should be sorted. How, sir? This question is very tricky if you don't understand this. Out of 8, selecting 5, 8C5s, that's okay. Sir, that 5 should be sorted. Remember, A is sorted. Sorted array combination is sorted. Remember this line. Sorted array combination is sorted. Sorted array combination is sorted. This is a very, very tricky problem. Sorted array combination is sorted. Sir, you are home or office right now? Sir, you are at home or office right now? I am at metro. In metro, I am teaching. Right? I am at metro. In metro, I am teaching. Mishra is asking, sir, you are at home or office right now? I am at metro. Arey Mishra, I will remove half leg. Mishra ji, I will remove half leg. Half leg I will remove you. Half leg. A serious discussion is going on. He is asking, are you at home or office? Ayush is saying that, Arey sir, control you too. Ayush, please inform to Mishra first. Ayush, please inform to Mishra first. Mishra is not controlling. Why should I control? Mishra is not controlling. Why should I control? Arey Mishra. Mishra is a plus member. Okay. Mishra is a plus member. Okay. Now I got clarity. Now. Mishra, I got clarity now. When I said I will remove half leg, when you said ha, then I got to know you are plus member only. But anyhow, let's go to next problem. Now listen everyone. This problem is very difficult. Listen. This problem is very difficult. Everyone have to understand. This problem is very difficult. Out of 8 people, listen. Out of 8 people, see this one. 8 people which are sorted. 8 people which are sorted. If sorted is not there, 8 people are there. Select 5 people. Such that all the 5 should be sorted. Out of 8 people, selecting 5 people such that it is sorted, then this problem may look little difficult. Because of sorted array, any combination will be sorted. Sorted array, any combination is sorted. Sorted array, any combination is sorted. Right? Fine. Right? I'm thinking that everything is fine now. Let's go to next problem. Can you see this? It is a really nice problem. Can you check once? Consider the process of inserting an element into a maxi where the maxi is represented by an array. Suppose we perform a binary search on the path from the new leaf to the root to find the position of the newly inserted element. The number of comparisons performed is. It is a really nice problem. I don't know how many people will understand this. Can you read this first? Can you check what is the answer of this? Check once. Consider the process of inserting an element into a max heap where the maximum, right, max heap is represented by an array. Suppose we perform a binary search on the path from the new leaf to the root to find the position of the newly inserted element. The number of comparisons performed is, some options are given, 4 options. Right? Let's check. I think he is talking about max heap insertion. He is talking about max heap insertion. Right? Let me take one example. Max heap insertion. Right, max heap, so maximum element at the root. Right? Let me give values. But when you say max heap, maximum at the root, so I think less people at the leaf, right? Let me write some values: 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, 160, 170, 180, 190, 200, 210, 220, 230, 240, 250, 260, 270, 280, 290, 300, right? 310, or maybe let me use some other number. With the max heap, check one time. With the max heap, please verify one time. Everyone, whoever watching, let's see one time. It is a nice problem. It's a really nice problem. One time, please go through it. One max heap tree available. So I written the elements from the bottom. Right? Bottom is small people. Top is maximum person. So it is the max heap. If you want, I will write the positions also. Let me write positions. Also. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. See this one: 16, 17, 18, 19, and so on. I done many times. It is a 31. Last one is 31. In the array, everyone know min heap tree or max heap tree will store inside computer in the form of array. Min heap or max heap will store inside computer in the form of array. Right? In the array they stored first place 310, second place 300, third place is 290, and so on. Last place 31. Now those people who are watching here, please let me know. Min heap tree or max heap tree contain n people. How many levels? Those people who are watching, please let me know. Min heap or max heap which contain n element, how many levels are there inside? Can anyone say? Min heap or max heap which contain n elements, how many levels inside? How many levels? Log n. So let me write log n levels. Min heap or max heap which contain n people, number of levels are log n. That's okay. Fine, that's okay. Can you help me now? In the min heap tree or max heap tree, if I want to insert one more element, where I will insert? Can anyone guess? Min heap or max heap, if I want to insert one more element, where I will insert? Yeah, Nishant is saying log n plus 1. Nishant, plus 1 minus 1, forget about. Asymptotically log n. Nishant, whatever you are saying may be true, but asymptotically go ahead. Asymptotically, because see the option. See, in the option nowhere log n plus 1. See, in the option nowhere log n plus 1. Even though your answer is right, Nowhere log n plus 1 is there. See, all are asymptotically. All are asymptotically. Nowhere log n plus 1. Right? So please be careful log n levels. Log n level. Can you help me now? In the min heap tree, max heap tree, if I want to insert one more element, where I will insert? Can anyone guess? Yeah, someone is mentioned. Not leaf node. Exactly not leaf node. Last place. Can you help me now? Who is the last place? If you want to insert an element in the min heap or max heap, where you have to insert is last place. Last place. What is the meaning? 31. Until 31 elements are there. 32. Here. 32. At this place you have to insert. Last, not last level. See, last level also correct. Leaf node also correct. Everything okay. But last place. Last place. Last place. Not leaf node, not last level. Maybe that is also worked out. But exact answer is last place after 31, 32. 32 place here. You have to insert the element at 32 place. You have to insert the element at the 32 place. Last place. Someone is mentioned 60 left. Exactly. If you want to insert a element, right, you have to insert at the last place. Yes, this place I have to insert. This place. If anyone remember, listen, this place you want to insert. Please listen. This place you want to insert. Let us assume that this element is 500. This place you have to insert. This element is assumed that 500. You know very well, in the min heap tree or max heap tree, if you want to insert a element, you have to insert at the last place. After inserting, you have to ask the parent. Right? After insertion is over, you cannot keep quiet. You have to ask the parent, Papa, am I okay or not? You have to ask, right? After insertion is over, you have to ask the parent, Papa, am I okay or not? You cannot keep quiet because it is a nice tree. Max heap is a nice family. Or min heap is a nice family. After insertion is over, you cannot keep quiet. After insertion over, ask the parent, Papa, am I okay or not? So you know very well, right? Papa is that kind of person, right? If you do the worst thing also, he may say, right, no problem and all. Very rare incident, he will say problem is there. Very rare incident, he will say problem. When you ask the right, Papa, do you have any problem? See this one. He said, according to Maxi, root will be more than the children. So when you ask Papa, is there any problem or not? He will say yes. Then swap it. So 500 here, 60 here. Again, he will ask his parent, Papa, am I done anything wrong? Yes, I think 220 and 500. Max means root is more than the children. So he will say yes, again swap. 500 here, 220 here. Again, he will ask his parent. Papa, am I done anything wrong? He say yes. So 500 here, 260 here. Again, he will ask his parent, am I done anything wrong? Yes. 500 here, 300 here. Again, he will ask his parent, have I done anything wrong? Yes. So 500 here, 310 here. Now, can anyone help me now? This entire procedure will take how much time? Can anyone guess? This entire procedure, what is the answer? See, total path, if you observe, every time compare, swap. If you observe clearly, log n comparison, log n swap, totally 2 log n, which is nothing but log n. Totally 2 log n, which is nothing but log n. Log n comparison, log n swap. Worst case. Log n comparison, log n swap. Totally 2 log n, which is nothing but log n. Are you getting till now? Are you got till now? If anyone didn't get, please let me know. Because one point is left out. If you get till now, please let me know. Yeah, I will do. Nishant, I will do that. Nishant, you may be correct also, but I will do within few minutes. Any doubt till now? So after insertion is over, you have to ask in that path. Right, Papa, do you have any problem? Yes, Pap. Do we have any problem? Yes, perhaps. So worst case, log n comparison, log n swaps. Totally 2 log n, which is nothing but log n. Fine. And one more thing. In this path, listen. In this path, I think let me go for another color. Let me go for another color. Listen, everyone now. See this one. In this path, if you observe clearly, the path where, right? So see, in this path, if you observe clearly, this is the path where everyone you ask, right? Like this. This path, if you observe, can anyone help? The green color path, whatever you see, in this path, you asked every person or not? The green color path, whatever I marked is, right? In that path, every person you asked. In the green path, from bottom to top, you asked every person. That is the worst case, okay. But in that path, every person you asked, every person. I think this is called linear search. The green path, what I marked, from bottom to top, every person you asked. Asking every person is linear search. So what I want to say is, in this path, every person you asked, linear search. See, log n people are there, log n people asking, log n comparison, log n swap. Okay, everyone you are asking, I don't have any problem. But unfortunate thing, what happened is, listen, everyone you are asking, I don't have any problem. But unfortunately, what happened is, careful everyone, you ask everyone. This is called linear search, log n comparison, log n swap. That is absolutely fine. But unfortunately, what happened is, let me remove one small thing. Let me remove it. You asked every person in this path. Okay, I'm okay. But let me remove this. Why I am removing, I will explain. Yeah. See everyone, in this path you asked every person, right? So that is called linear search. But one thing I want to ask you, listen, let me remove these arrows also. In this path, every person you asked, right? Fine, that's fine. You asked every person, there is no problem. But see what the problem. You asked every person, but one thing I want to ask you. This green color path, if you observe, is it sorted? Can you check? This green color path, if you observe, is it sorted? See, until here you see, until here. Green color path, if you observe, right? Green color path, if you observe, see this one. Until here, everyone is sorted. Check. Until here, everyone is sorted. See. In the green color path, everyone is sorted. Even though everyone is sorted, if you want, I will read also. See this one, 310, 300, 260, 220, 60. Forget about the new person. Is the new person. Forget about the new person. Old people, if you observe in this path, everyone is sorted. See, 310, 300, 260, 220, 60. All are sorted. In this path where you are visiting, in this path, if at all are there in the sorted order, why are you applying linear search? Why don't you apply binary search? In this path, all are already sorted. Why are you asking one by one? Why don't you apply binary search? Now I will go to the problem. I will read once. Can you see the problem now? Read it. Read now. If at all the path which you are traversing, in that path everyone is sorted, why are you applying linear search? Why don't you apply binary search? The path which you are visiting, see this one, see everyone. Consider the process of inserting an element into max heap. You know the story what I explained is insertion, where the max heap is represented by an array. That is also okay. Suppose we perform a binary search on the path from the new leaf to the root to find the position of the newly inserted element. Means what you want to say is, right, after insertion is over, while asking the parent, normally we will ask every person. That is the reason log n comparison, log n swap, 2 log n order of log n. Because of these all are sorted in this path, why are you going linear search? Why don't you apply binary search? If you do that, what will happen? Let me check. If you do that, what will happen? Let me check. Let me check now. So let me take some other color. I will go ahead. I think let's check. I will go ahead. Yeah, black color. I'm going. Black color. Okay, fine. Yeah, this blue color. Now listen everyone now. So I'm starting. See this one. So instead of asking everyone because of it is sorted, why can't I apply binary search? Some people are asking, sir, how to apply binary search? Listen, how to apply binary search? Everyone listen. 32. Careful. How to apply binary search? Very simple. 32 can be written as 2 power 5. Can be written as 2 power. So when you say binary search, right? This power is 5 there, 5 by 2 you do. 2 power 5 by 2. 2 power 5 by 2. Just to do 2 power 5 by 2. So it will become 2 power, right? 5 by 2 becomes 2.5. You can take 3 also. You can take 2 also. Take whatever you like. I am taking 2 square. See this one. This person 32, instead of asking his parent, right? He will ask, listen, this 500 will ask. This 500 will ask. What is the answer? 2 square means 4. He will ask. Listen, he will ask. Instead of asking the parent, he will ask him, am I okay or not? You don't ask the parent. He will ask the middle person. See, he is the middle person. He will ask middle person, am I okay? See this one. Child is 500. Sorry, child is 500. Parent is 260. Is it okay? He said no. Whenever it is a maxi tree, root will be maximum. So this person is not asking parent. He is asking middle person. Middle person is this person. Am I okay or not? Middle person said no. Whenever middle person say no, he is not okay, then you have to check open. Again middle person. Can I help you know? 2 power 4 means 2 square. 4 means 2 square. 2 square by 2 you do. 2 power, right? By 2 you do. It became 2 power 1. So 2 power 1 means 2. Ask the again middle person. Am I okay? 500 is asking 300. Am I okay? He said no. Because 500 should be more. He should be upper. Again he said no. Again once again by 2. So do divide by 2. See this one. First by 2. Again by 2. Again by 2. Just do like that. Can you help? You know, when you do by 2 by 2 by 2 by 2. If n is always by 2 by 2 by 2. N is always by 2 by 2 by 2. N is always by 2 by 2 by 2. It will lead to log n. It will lead to log n. But what you are doing is, you are dividing log n by 2. Again log n by 2 again. Again log n by 2 again. So it will lead to log n. Remember, if you apply binary search, because of you are not going, right? Because of you are not going parent, you are going middle, right? So if you observe clearly, log n comparison, because you applied binary search. Log n comparison, because you applied binary search. See this one. Some people are asking log n comparison side on. See this one. This 500 purpose, I applied log n comparison. Finally, I got to know that, right? This is the correct place of 500. In the maxi tree, 500 correct place is this. To know 500 correct place is this one. Log n comparisons are over. Now some people are asking, so what is the meaning? That 500 will goes to here. That 500 will goes to here, but this 310 will goes to here. But this 300 will goes to here. This 310, this 300 will goes to here. This 260 will goes to here. This 220 will goes to here. This 60 will goes to here. Remember everyone. Log n comparisons okay, but SPAPs are log n. Log n SPAPs. SPAPs you cannot do binary search. 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 Log n comparison, log n SPAP, totally log n plus log n, log n plus log n, which will goes to log n. So remember, time complexity is still log n. If you apply binary search also, time complexity log n only, because comparisons are same. Sorry, comparisons are improved, but SPAPs are same. Comparisons are improved, SPAPs are same. Comparisons are improved, but swaps are same. Comparisons are improved, but swaps are same. Now some people are asking, some people they asked comparison. So whatever they will ask, we have to give. Right? Let me say, maybe I have to read the problem again. Suppose we perform a binary search on the path from the new leaf to the root to find the position of the newly inserted element. The number of comparisons is this one. Number of comparisons log n. True. If time complexity log n. Comparisons are log n. Time complexity log n. So answer for this problem is log. Right? Answer for this problem is log. Check once. It is one of the toughest problem. It is one of the toughest problem. Very difficult to explain, but I tried. It is very difficult to explain, but I tried. So listen. So the amount of time required, to insert a element in the max heap, the amount of time required to insert element in the max heap using binary search log n, using linear search log n, amount of time complexity both log n. Binary search also log n, linear search also log n. But a comparison, binary search is log n comparison, right? Linear search is log n comparison. So performance is improved in terms of comparison. Performance is not improved in terms of time complexity. So please check once. If anyone having doubt, let me know. If anyone having doubt, let me know. Check one time. Yeah. Yeah. So let me say something about Unacademy also. Right. So there is a in Unacademy there is a in Unacademy 20% of offer is going on. 20% off. 20% of offer is going on. Those people who are serious about GATE exam, right? If you are serious about GATE exam, it is the correct time to join. It is the correct time to join. Trust me, many practice classes, RIC, rank improvement going to start. Crash course going to start. There are many advantages. Right? Plus course is one. Plus course already available. Plus course and iconic course, right? Almost similar in terms of the lectures, but iconic having so many facilities. So, right, if you join the Unacademy, right, iconic classes you can attend. Next one, mentorship you will get, and one more material you will get, and one more thing, right? Test series you can write, right? Rank improvement course going to start. Expected questions also going to start. If you are really serious about GATE examination, right, it is the correct time to join the Unacademy. It is the correct time. Second year people, it's the correct time. Third year people, it is the correct time. Those people who want to crack 2023, it is the correct time to, right, correct time to join Unacademy. Use the referral code ReddySir. Use the referral code ReddySir. See this one, free course itself is, you are getting this kind of explanation. If you join the paid course, you will get a lot of advantage. Free course itself, right, free lecture itself is this much quality. Paid course, you can imagine how much quality you will get. You will get a lot of advantage, right? 20% off is going on Unacademy notes also and test series also. Use referral code ReddySir. So this is me in Unacademy. I am teaching algorithm classes, data structure classes, programming classes. Next one, right, TOC, compiler design, computer network, discrete mathematics, right, digital. Very soon I will start the digital also. So these are the courses. They are recorded already, live also. They are recorded also and live also. So please utilize this wonderful opportunity. If you are serious, without thinking 1 minute also, please join Unacademy as soon as possible. If you join the iconic course, these many advantages. My suggestion is, please go to iconic. My suggestion is, without thinking anything, go for iconic. Use the referral code ReddySir. Use the referral code ReddySir. Right, go to iconic courses. Right, let's go to next problem. It is a sum of subsets problem. Can you check one time? Will you give answer or not? Verify. It is sum of subsets problem. Please verify once. No, Anant, you can follow directly. Nothing required, Anant. Directly you can follow. Yeah, please, can you see this? The sum of subsets problem is defined as follows. Given a set of n positive numbers and a positive integer w, there is a subset of S whose elements, right, whose elements sum to w. A dynamic programming for solving this problem uses a two-dimensional Boolean array X with the n rows and w plus 1 columns. Right? Xij is equal to right, I range from 1 to n, j range from 0 to w is true if and only if there is a subset a1 to an whose elements sum to j. Which of the following is valid for I range from 1 to n, right, j range from 0 to w? I think it simply is, right, sum of subsets problem. No logic, nothing. Sum of subsets problem. It is exactly sum of subsets problem. No logic, nothing is there. Exactly what is the sum of subsets problem is. So Xij is equal to, right, Xij is equal to simply, right, a particular element you may take, you may not take. A particular element you may take, you may not take. Two choices. Taking means, right, taking or not taking, both are I minus 1. It is also I minus 1, it is also I minus 1. Whether you take or not, right, that element will be over. Right, x of I minus 1, right? If you take from the j, a of I will be eliminated. If you don't take, simply if you don't take, right, j only. If you take, right, so from the j, a of I will be eliminated. If you don't take, it is not eliminated. So remember it is an R operator. You may take, may not take. Both the things cannot happen. R operator. You may take, you may not take. But whether you take or not, element will be over. If you take, right, from the j, a of I will be eliminated. If you don't take, j only. Answer is B. So if anyone not getting, this is exactly sum of subsets problem. It is exactly sum of subsets problem. Yeah, I think Udayan, it is not over, you may not get it. It is not over, you may not get it. Right? After explanation is over, easily you will get. After explanation is over, easily you will get it. Right? You may not get. So if anyone don't know sum of subsets problem, if I explain, it is almost like a 3-hour story. I cannot explain. It is there in the iconic course or plus course. Very clearly I will explain. Within few days I will start this. Within few days I will start this. Right? Dynamic programming little bit is pending, so I will do that. Right? Which entry of the X is true? It implies that there is a subset whose elements sum to W. Right? I think X, right? X1W, XNW, right? XNW, XNW. N people are there. Which entry is saying, right? Which entry of the array X is true? It implies that there is a subset whose sum W, right? This one. N range from 1 to N. Yeah, exactly. Right? I think C. So this problem you may not get. Really, it's not possible now. Right? So I think, right, leave that one. Let's go to this problem. I think he's asking in this problem, previous one, if you don't know sum of subsets problem, you cannot get it. Right? This problem, can you see? Consider the following C program that attempts to locate an element X in an array, right, Y using binary search. I think in this problem, he is asking binary search. He is asking something about binary search. So binary search program is given. See, binary search program started here, ended here. You know binary search very well, right? First to find mid element. If mid element is your element, right? Mid element is this one. Mid element is, right? Mid element is, right? X. What is the mid element? I think K. K is the mid. Y of K is mid element. If mid element is less than X, mid element is less than X, something you are doing, right? Otherwise, I think it's something like binary search. If condition true, this is the story. If condition is fail, some other story. Please take care. Binary search program is given. Within few minutes, I will explain. You just check yourself. It is a simply binary search program, right? Fine. Now see what he is asking. On which of the following contents of Y and X does the program fail? What I want to say, in these inputs, this one, option A, option B, option C, option D, right? So, right, listen, this algorithm having some flaw. For which input this algorithm fail? The algorithm, the binary search algorithm, what is given, some flaw is there, that, right? Because of that flaw, one of the input it will fail. Which input? Can you try? Remember, array name is Y. Element which you are checking is X. It is a binary search program. And one more, if you want to apply binary search, array should be sorted. Right? First input, if you observe, ascending order. Second input, if you observe, that is also, I think, ascending order. Third input, right? Elements all are same. Fourth element, right? Sorry, fourth array, I think ascending order. So please check. First ascending, second ascending, third one is equal, fourth one is ascending. Right? I think in the first array, you are searching for element X, which is less than 10. Second array, you are searching element X, which is less than 1. Third array, all are same. You are checking X greater than 2. Fourth array, you are checking for X, which is more than 2, less than 20. And X is even. Can you verify? Ascending, equal, ascending. Please verify this program. Right? This is the binary search program. For which input this will fail? Can you check once? Yeah, Anant. First complete the notes first complete the classes at anywhere. If you have doubt, you can open the printed notes. You can check one time. Check what will be the answer. So let me try once. Let me go for the option C. That all elements are same. I am checking for x greater than 2. Right, see this one. I am going to the option C. All elements are same with x greater than 2. What does the meaning? I want to check element x is equal to 5. I want to check x is equal to 5. All elements are same. Remember, all elements are same. Right? I'm checking for element x is equal to 5. These are the indexes. Some elements. Right? Now see the first one. See the first one now. I think if you want, I will write the remaining elements also, so that you will get more clarity. So indexes I written 1, 2, 3 and so on 10. Right? Now see, I is equal to 0, j is equal to 9. I is equal to 0. I think let me write. Because of he is saying start from 0, I will start. Let me use another color so that you will get clarity. These are the indexes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? This is I 0, j 9. Okay, that's fine. Now listen, do while. Everyone know do while loop. It is a do while. Do while. It is a do while loop. What the do while loop is, first it will do, then it will check condition. First it will do, then it will check the condition. Right? Let's start. K is equal to, right, 0 plus 9. 0 plus 9 is 9 by 2, 4.5. 4.5. So K is equal to 4.5. Right? Take the floor value or ceiling value, that doesn't matter. And one more thing is, to get the clarity is given. See, floor or ceiling, how I know? Integer. So 4.5 is 4. So I think K value is equal to 0 plus 9 by 2, which will goes to 4.5. So because of K is an integer, 4.5 becomes 4. Now next one. See the next one. If y of 4 means this one. If y of 4 is, because I am checking for element x is equal to 5. Be careful. If y of 4 is 2 is less than 5. True. Then I is equal to k. Right? If at all I am looking for 5, the middle element is less than the 5. Then what will happen is, my element should be on the right side. So you bring the I is equal to k. I is here. K no change. Right? It is a do while loop. It is a do while. I think one time you done, if condition true, I is equal to k, then you have to check the while. One time you done. Do while means what? First to do, then go for while. Now check the while. What is the while? While y of k. Y of k means y of 4 not equal to x. True. And I less than j. I value is 4. J value is 9. Condition is true. Right? Again go. Again same story. Do what? Right? So again do. So k is equal to I plus j by 2. What is I value? 4. 4 plus 9. 13 by 2. 6.5. So 6. Right? 6. Next one. After 6, next one. What is the y of k? 2. Is 2 less than 5? Condition is true. Again same story. I is here. Right? J is same. Right? Right. I is equal to k. Fine. Same story. Else j is equal to k. That's okay. I is equal to. Again while condition. What is the while? Right? Y of k. Y of 6 is 2. 2 not equal to x. Condition true. End I less than j. I value 6. So j value 9. 6 less than 9. Condition true. Again do while. So can you help in I plus j? 6 plus 9, 15 by 2, 7.5. So 7. Go to the 7. So y of 7, 2. 2 less than x. Condition true. Then I is equal to k. I here. Again same story. Condition is true. Right? Y of k. Right? I think I becomes k. That's okay. Then y of k 2. 2 not equal to 5. True. and one more thing is 7 less than 9, condition true, again same story. Mid element 7 plus 9, 16 by 2, 8. Next one, y of 8, 2 less than 5, condition true, so I is equal to k. I think it came like this one, else right, that's okay. Again same story, y of k, y of 8, 2 not equal to, right, 2 not equal to 5, condition true. And one more, I less than j, condition true, again same story. What is the answer? 8 plus 9, 17 by 2, 8.5, so 8. I think if you observe clearly, right, 8.5, 8. Again same story. I think if you observe clearly, at this place, it is trying to go into infinite loop. I think it is trying to go into infinite loop. If anyone is not getting I value 8, j value 9, I value 8, j value 9, same. Because 8 plus 9, 17 by 2, 8 point something. 8 point something. Again 8. I think it is keep on going. It never go out also. Now let me check. Consider the following C program that attempts to locate the element x in an array y using binary set. The program is erroneous. Right? What will be the reason? See. And which of the following contents of the y and x does the following program fail? Remember for option C it will go to infinite loop. Option C it will go to infinite loop. C option infinite loop. C option infinite loop. Please take care. If anyone is not getting, you can check one time. If anyone is not getting, you can verify one time. Right? Binary search algorithm is applied. Small mistake done. Right? Option C it will go to infinite loop. 8 plus 9, 17 by 2. Right? 8.5 means 8. Every time 8, 9. Every time 8, 9. Every time 8, 9. Condition is always true. So it is keep on going infinite loop. Other people don't have any problem. Because of because of increasing, it don't have any problem. Right? The correction needed in the above program to make it work properly. The correction, right, you have to do to make it work properly. If y of k less than x, then I is equal to k plus 1. J is equal to k minus 1. I is equal to k plus 1. If y of k is less than x, so I is equal to k plus 1. Else j is equal to k minus 1. I think answer is A. So here k plus 1. This is the change you have to do. Why are you checking the same thing again? You have to do this. If y of k is less than x, so I is equal to k plus 1, else j is equal to k minus 1. The same binary switch program I written in the classroom, right? There I written k plus 1, but I written k. Same program I written in the classroom. In the classroom I written k plus 1, but I written here k. Small mistake done. So by seeing this problem, you have to understand one thing. In GATE examination, all questions will be from basics only. In GATE exam, most of the questions are right. In GATE examination, most of the questions are from basics only. Right? They will verify how much strong you are in the basics. GATE exam is basics. How much strong you are in the basics, they will ask you. Right? So those people who are serious, if you are really serious, please join the iconic batch. Please join, right? Second year people, if any second year person, second year is the correct time, third year is the correct time. If anyone is a second year, third year, please start preparation now. Second year, third year, please start preparation now. If you are fourth year starting, then also you can join. Don't join fourth year last moment, don't cry. Fourth year last moment joining and don't cry. Second year starting, start now. Third year starting, start now. Fourth year starting days, you can start now. If you join fourth year last moment, it will become difficult. right? It will become difficult. Possible, but it will become difficult. Those people who are serious about GATE examination, my suggestion is please join Iconic. Right? Let's go to one more problem. Let's go to one more problem. This problem, can you check this? It is also a nice problem. Can you verify? Choose a value for x that will maximize the number of minimum weight spanning trees. So you know very well, minimum weight spanning trees need not be unique if edge weights are repeated. If edge weights are repeated, minimum cost spanning trees need not be unique. The number of minimum weight spanning trees of G for this value of x is, so for which x value, right, number of minimum cost spanning trees are more. I am repeating problem again. Choose a value for x that will maximize the number of minimum weight spanning trees. The number of minimum weight spanning trees of G for this value of x is, right, is asking finally the number of minimum weight spanning trees of G for this value of x is. And one more, you have to choose the x value such that it will maximize the number of minimum weight spanning trees. Okay, I will try once. Let's see everyone. Minimum weight spanning tree, you can apply either Kruskal or Prim's. Minimum weight spanning tree, you can apply either Kruskal or Prim's. I am going to the Kruskal. Right? Anyone you can apply. I am going to Kruskal. Can you help me now? First minimum. I am going to Kruskal. Can you say first minimum? First minimum is 1. Forget about this x. This x afterwards we will see. Don't worry. Right? First minimum 1. Right? First minimum is 1. So second minimum. Suppose assume that if the first minimum is 1, second minimum, let us assume that second minimum is x value 2. If I take x value 2, let us assume that x value 2 I am taken. First value is 1, second value 2 I take. Assume. Until now, one possibility only. Can you help me know what is the third minimum? First minimum 1 I am taken. Let us assume that second minimum is x, assume 2. Until now only one choice. But I want the minimum cost spanning tree should be as maximum as possible. If I take x value 2, what will happen? Let me verify. So can you help me know what is the third minimum? Third minimum is 3. Third minimum is 3. I think no problem. Till now no problem. Till now no problem. If I take x value 2, until now only one choice. Now see everyone now. Until now only one choice. Right? Until now only one choice. So next minimum is 4. Can I take this 4? Yes. Can I take this 4? Yes. Can I take this 4? No. I think if I take x value 2, I will get only 2 MSTs. I think either I can take this 4 or I can take this 4. So x value 2, I will get 2 MSTs. Now some people are asking x value 1, then also 1 MST. Then also x value 1, then also 2 MSTs. Then also 2 MSTs. Because this only, either you can change this or you can change this. Now let's go to x value 3. Let's go to x value 3. Isn't that x value 3? So first minimum, second minimum, third minimum, I think for the four purpose, either you will take this or either you take this. I think 3 also same. 3 also same. Now come to the game. Listen, now come to the game. Let us assume that it is not 3, it is a 4. Let's see. Let us assume that it is not 3, it is a 4. It is a 4. It is a 4, assume. Now let's check. Can you help me know? First minimum. Very interesting answer. Suppose that x is not 3, x is 4. X is 4. If x is 4, see this one. First minimum, second minimum, fine. First minimum, second minimum, until now fine. Now third minimum is going to be 4. Third minimum is going to be 4. This 4 I cannot take because of loop. Right? This 4 I cannot take. I think I can take this. I can take this. First minimum, second minimum, confirm. Right? I can write if I take the 4, if I take x value 4, if I take x value 4, if I take first minimum, second minimum, I think to cover this one, then also no use. If I take x value 4, first minimum, second minimum, I think that is the only thing. There also 2. Please check. Now x value 5, I think the game is there with 5. X value 5. If x value 5, what happened is, first minimum, second minimum over. Third minimum 4. I cannot take this 4 cycle. Right? And one more thing. See this one. I can take this 4. Or I can take this 4. Any one. Here two choices. But whenever I will say 5, I can take either this 5 or I can take this 5. Any one of the 5. I cannot take both the 5s. Any one of the 5 I can take. Next one. I can take this 4. I can take this 4. Can you help in how many choices? Can anybody help in? I'm thinking, if you take x value 5, 4 choices. Can you verify? If you take x value 5, 4 choices. So if anyone is having doubt, see this one. If anyone is having doubt, I am giving the answer. See, this 4 fixed. If anyone having small doubt also, this 4 fixed, right? Either this 5 or this 5. You cannot take both. Either this 5 or this 5. So I think to this one, right, two choices. In the similar way, to this also two choices. So here two choices, here also two choices. 2 into 2, totally 4 choices. Remember, I am writing x value 5, 4 choices. It is a really nice problem. Very less people can do that. Very less people can do that. 2 into 2, 4. It is a really nice problem. X value, listen, x value 2, 2 choices. X value 1, 2 choices. See, always left side two choices coming. Always left side two choices. But right side is one choice for x is equal to 2. Right side is one choice for x is equal to 1. Right side one choice for x is equal to 4. Right side two choices for x is equal to 5. So what is asking? Right? The number of minimum weight spanning trees of G for this value of x is 4. Next one, choose a value for x that will maximize minimum weight spanning trees of G. I think x value 5. It is a really nice problem. Really nice problem. Really nice problem. Verify once. Four minimum weight spanning trees. X is equal to 5. Exactly. Left two choices, right two choices. Left two choices, right two choices. So left is always two choices coming. Right is only one choice is coming. Right? For the 2, for the 1, for the 4, for the 3 also. For the 3 also. Can you try what the answer of this problem? I think it is a very simple problem. Sir, आप भी physics वाला में आ रहा हूँ. Physics वाला, should I teach physics or what? I don't know. Should I teach physics? Fine. Let's come here. Arey, emotion, right? You came here, right? So listen this all, right? What is going on, right? Thank you so much for praising me. I'm very happy. Thank you so much, right? But it's not good, right? Thank you so much. Thank you so much, right? Let's see this problem. Consider the following functions from positive integers to real numbers: 10 root n, n log n, and 100 by n. 10 root n, n log n, 100 by n. Right? I think if you observe clearly, among all of them, listen, among all of them, which one is smaller you are thinking? Among all of them, which one is smaller you are thinking? I think this is the first smaller. Because decreasing function, 100 by n, it cannot be, right? 1 also, less than 1. Right? I think he's asking increasing or decreasing? Increasing order. So I think first one is 100 by n. First one is 100 by n. So A cannot be, C cannot be. Next one, I think second one is 10 at the 2. So it is a decreasing function. It is going to be constant function. So after decreasing function, constant function. So I think right? I think log n, right? That is the reason it is wrong. Right? Next one, third one, if you see, this is the third one. This is the fourth one. This is the fifth one. So third one is log n. Right? Fourth one is root n. Fifth one is n. Yeah, excellent. So B is the answer. B is the answer. Sir, you are so cute. Are I am cute. Your name is okay. How your name is okay? Are okay? Okay. How your name is okay? So AB developers saying next question. I think AB developers not eating food also. He want only questions. AB developers don't want food also. He don't want food also. He want always questions. Sir, next question. Sir, next question. Sir, next question. Yeah, dare to dreamer. Dare to dreamer. Arey dreamer, right? What you think about the results? What you think about the results? Right? Just to do. My suggestion is just learn as much as possible. Just learn as much as possible. See, I am not qualified in GATE 2022. I am confident after watching your TOC Algo DS lectures from Plus, but still failure is haunting me. So I think dreamer, what you are doing exactly this entire year? 2022, you are not get a nice rank. From that day onwards, you could have prepared so well. But how many subjects you completed? How many subjects you completed? Rahil is saying that I love my heart. Who said to you to love my heart? Okay, you love your heart, that's fine. Right? You love, right? I love my heart means, right? You love your heart. Rahil, one last question, please. One last question, please. Check one time. This is a very dangerous problem. Can you try? It is a whopping challenge. It is a whopping challenge. Who will give answer for this? It is a whopping challenge. Can you try this? It is a whopping challenge. Who will do this problem? Let's check. An array A contains an integer. We wish to sort A in ascending order. We are told that initially no element of A is more than a distance k away from its final position in the sorted list. Assume that n and k are large and k is much smaller than n. Which of the following is true for the worst case complexity of sorting A? Okay. Check once. What is the answer for this problem? Right? Listen. This problem. See, very less people can do this problem. Listen, everyone. This problem, very less people can do. Very less people. So listen, it is very difficult. Very difficult. So I am giving hint also. I am giving hint also. Everyone, listen. I am giving hint also. This problem, I am giving hint also. Right? That is, listen. That is apply heap sort. Apply heap sort. So every time, because of I think k people, log k, n time, n log k, that small mistake also problem will come. Can be sorted with n log k compare, but not with fewer than operations. So answer is D. Every time log k. See, I am giving the hint also. Every time log k, n times. Answer is n log k. It is a very nice problem. Very nice problem. It's a very nice problem. Apply heap sort. It's a very nice problem. Apply heap sort. Check once. Right? It's a really nice problem. Some people are asking, sir, how? I am giving the hint also. Listen, some people are asking how. I am giving the hint also. Listen. You want to sort the array A which contain n people. See the beautiful thing here. See the beautiful thing. You want to sort the array A which contain n people. But the condition is in that array every element is there. K positions away to its correct position. Supposition that I am the first smallest element in the array. I am there from the first place to k positions away. The first smallest element actually should be there in the first place, but it is there to its actual position, right? K positions away. What is the meaning? So for the first place competitor, k places away. So what you do is, in the array, k places people until k whatever is there from first to. Take until k people, first place to until k people, whoever there, take all of them, create mini heap first. Don't create mini heap for all the people. First k people you take, create mini heap. First k people you take, create mini heap. After creating, delete one time, then first minimum k. So listen. So k people create mini heap k time, then delete one time, log k. Now I think in the second place, the person who is fighting for second place is k positions away from there. So one more element, I think k plus one element you take, insert in the min heap, delete one time. So first time, I will give that, right? I will give the total time. See, first time is k plus log k for the first person. Remaining people, if you observe, one insertion, one deletion, 2 log k. How many times? N minus 1 time. So finally, 2 log k into n minus 1, right? This is the one which will dominate. So it will become n log k. This is the answer. First person, k people create mini heap, one time delete. Next time onwards, one insertion, one deletion. 2 log k. Like that, do n minus 1 time. N into log k. Right? Right? Please check this. So this is the really nice problem. Very less people can do. Very less people. I given the hint also first. Apply heap sort. Some people are asking, sir, how you know apply heap sort? How you know? He said that every element is k position away to its actual position. Every element is k position away to its actual position. If my correct element is k positions away to its actual, then why I will take all? Take only k people. If my actual competitor is right k positions away, then why I will see everywhere? Only k positions away only take. Create mini heap, delete one time, you will get the winner. But second person, if you observe, right, k positions away from there, what do you mean? One more extra element. So every time one element inside, one delete. Every time one element inside, one delete. Every time one element inside, one element delete. So every time 2 log n 2 log k, 2 log k, 2 log k, 2 log k, n minus 1 time. First time mini heap is not available. For k people create a mini heap using build heap method. So k. Deletion is log k. K plus log k for first time. Second time 2 log k, 2 log k, 2 log k, n minus 1 time. Finally n log k. N log k. Right? Fine. Yeah, that is the keyword here. That is the keyword. See, if that keyword is not there, right? Right? That if that keyword, what is that keyword? Every element is to its actual position, k positions away. If that is not there, it will become n log n. You have to apply only math sort. If that is not there, it could have been math sort. If that is not there, see, every element is k positions away to its actual position. If that keyword not there, I could have went to the math sort. It could have been n log n. Now, if you see the option, can you see the option? Option C, n log n. At that time, answer is n log n. Every element is, see this one. This is the major line. See this one. See this one. No element of A is more than a distance k away from its final position in the sorted list. This is the major keyword. Initially, no element of A is distance k away from its actual position. This is the major. If this line is not there, answer B. If that line is not there, answer B. If that line is not there, then answer B. Because of that line, it became n log k. And one more, some people are asking, A can be sorted with k into 2n comparison, but not fewer. I don't think so. For k people create mini heap. Every time one coming, one going. Sir, because it is mentioned sorted list, we can think of math sort or heap sort. See, if nothing is mentioned, math sort. If nothing mentioned, math sort. K positions away, right? Heap sort. Next one. Completely unsorted, quick sort. But most of the elements are sorted, insertion sort. If the question contains most of the people sorted, insertion sort. If the question contains, right, array completely unsorted, quick sort. Array contain nothing is mentioned, math sort. K positions away, heap sort. Someone is saying that can we use binary search? Here sorting purpose, why you use binary search? See this one. Which one of the following is true for the worst case complexity? For sorting. Sorting purpose, how can you use searching? Sorting purpose, how can you use searching? Sorting purpose, how can you use searching? Right? Fine. It's a really nice problem. Please take care. It's a really nice problem. One of the best problem I ever seen. This is one of the best problem I ever seen. See, it may be looking difficult to you first time. When I am doing first time, I got lot of pain by seeing this problem. When I see first time this problem, I got lot of pain. I got lot of pain. When I see first time, it pained me a lot. It pained me. I almost cried. What is the logic behind this? What is the logic behind this? After some time, I got the idea. So I laughed to myself. Okay, this is the logic. Okay, this is the logic. First time I got lot of pain. When I reading this one, I think what way I can solve it. I can solve it? And keep on thinking like this. I got idea. Okay, fine. Sir, will you cover non-comparison based sorting algorithm for GATE? Yes, of course. Of course. Of course, I am covering that also. Can you see this problem also? Can you see this problem also? What is the answer of this? It's very simple. Can you complete this also? Arrange the following functions in asymptotic increasing order. Arrange the following function in asymptotically increasing order. Arrange the following function in asymptotically increasing order. Right? I think it's a nice problem. Let's check one time. It is something like 1 lakh n. It is something like 1 lakh n. Or maybe 1 crore n. Anyhow constant. 1 crore n. It is power. It is a power n. It is n square. It is n power. It is n power 0. N power 0.99999 into log n. Into log n. Right? Fine. I think a very nice trick is there. Very nice trick is there. Let me check once. So this log n is not in the power. This log n is not power. So I think everyone know. Among all of them, bigger one. Among all of them, bigger one is this person. Is the exponential. F3 is the exponential. I think F1, F2, F3, F4. F3 is the larger one. What do you want? Increasing order. F3 is the final. See, F3 final. So it cannot be the answer. F3 is final. Because F3 is the exponential function. Right? It may be looking like 1.00001 whole power n. You may be thinking it is a 1 and all. No. Right? So it is because of it may be increasing slowly, but it is exponential. F3 is the bigger. F3 is the bigger. Right? Now see the next one. See this one. F1 if you see, listen, F1 if you see n power, right, 0.99999, that's fine. Something like that. Into log n. That is the F1. But F2 if you see, forget about constant, n power, see this one, 0.9999 into n power 0.1 or 001. 001. So n can be split into two parts. N power 0.999 dot, right? So into n power 0.0001, something like that. If you want, you can keep one more 0. I don't have any problem. Right? Fine. That's okay. That's okay. So I'm talking about F1. I'm talking about F2. Right? I think this is the common part cancel. So remaining here if you observe, right? Remaining here if you observe log n. But remaining here, if you observe n.0.001, remember this is bigger. One is logarithmic, one is linear. So F2 bigger. F2 is bigger. Right? I think what about F4? Of course, F4 is bigger. So I think after F3, next bigger is F4. After F3, next one is going to be F4. So it cannot be the answer. Answer should be either this or this. And one more, F1 and F2 I already confirmed. F2 bigger. F2 bigger. So this cannot be the answer. Answer is D. Answer is D. Answer is D. Please see F1, F2. Please see F1, F2. See, everyone know, comparing F1, F2 bigger means comparing F2 compulsory, right? N square bigger means F4 bigger. Comparing F1, F2 bigger, comparing F2 compulsory F4 bigger. Comparing F4, F3 bigger. So over. So answer F1, F2, F4, F3. Answer is F1, F2, F4, F, right? F1, F2, F4, F3. D is the answer. Check if anyone having doubt. This is also similar. Can you go ahead? This is the last problem of today's class. This is the last problem of today's class. Can you check this also? Sir, please help me with this question. What question you have? What question you have? Ratul, what question you have? Where you posted? Yeah, let's try once again. Let's try. I think he also want again increasing order. He also want again increasing order. See, one is 2 power n, one is n power 3 by 2, one is n log n, one is n power log n. Right? Fine. This can be written as n power 1.5. This can be written as n power 1, n power, right, 0.5. This can be written as n into root n. This is n log n. This is n power log n. So n log n, n power log n is bigger, okay. But n log n, n root n is bigger. Be careful. 2 power n anyhow, right? 2 power n and n power log n. Who is bigger? That is going to be n. This is going to be log n into log n square. I think this is bigger. Is the first number 1 bigger? Number 1 bigger. So I can give number 4. Next is the number 2 bigger. Means 3. This is 2. This is 1. So first is 1, F3. F3. Second one is F2. What is the first one? What is the first one? F3. What is the second one? F2. What is the third one? F4. What is the fourth one? F1. I think answer is A. I think answer A. So I think Ratul for this one what you do is I is equal to 1 you take, right? See what is going on. I is equal to 2 you take, what is going on. I is equal to 3, what you just do like that 5 times. Some series going on, verify. Right? Just to do 5 times. I is equal to 1, I is equal to 2, I is equal to 3, I is equal to 4. Just to do 5 times. You are able to see one series going on. Right? Just find out one series. I is equal to 1, I is equal. Otherwise, in one of the practice class, I will solve. In one of the practice class, I will solve. Is it okay? Answer is A for this. Just to find out I is equal to 1, I is equal to, just to do 5 times. You will get the clarity. I think this one may be master theorem you have to apply. Please verify one time. Right? So until here, I am stopping here. Right? Tomorrow we'll see the remaining problem. Right? Thank you so much. Right? See you everyone. Right? In the next class. Right?